Shilky. Yeah. Shilky. Yeah.
Sorry about that.
That's fine.
Sorry. Very last.
Once he's got it pulled up, tap once to advance. If you
Okay.
want to go back and slide to the right. If you want to go forward and slide, you can slide to the left. If you have a video to play, tap it once to play. If you need to pause in mid-video, just let us know.
Okay. So the slide will advance, and then I tap the video.
Yes.
Start it. Okay.
So if you're on the slide that has the video, tap exactly where the video is. and it
Gotcha.
should pop up.
Okay. Very good. Hey, you all set?
Yeah.
Okay.
Sorry, Rick.
No, that's right. Hey, good afternoon. Rick Shilke from Nishati. I'm the U.S. government lead for Nishati Incorporated. And thanks to Bill and to the Innovators Corner team for the opportunity to participate today and to tell you a little bit about Nishati. Before I get into what we do and who we are, I'd really like to kind of give you an idea of what it is that drives us every day and how we tick. So, starting off talking about energy challenges in the expeditionary environment. It's not new news to anyone, particularly here at this conference, that digital capabilities have expanded tremendously over the last 15 years on the battlefield. And in the last, even 2001 to 2010, the Marine Corps noted that their radios had increased by 250% and their computers had increased by 300%. Digital capabilities have now progressed down to the squad level, in some cases to the individual warfighter level. What that means is now there's a very high premium on having reliable and adaptable power on the battlefield. The need to have power everywhere and in all these different forms brings with it a price or a challenge, and that, in this case, I'm calling it the expeditionary power dilemma. And that is that while diesel generators and vehicles are certainly a vital source of power on the battlefield and will be for the foreseeable future, they have an Achilles heel. They're not typically very adaptable to the fluid and dynamic nature on the battlefield, and those limitations lead to capability limitations. Some are recognized and some are not always recognized, such as the difficulties of maintaining and logistically supporting these systems, particularly as you get into smaller scale power requirements. And solar is going to solve all of these problems. Thank you, Bill. That was the applause line.
Yeah,
Bill said that was going to kill. So I went with it. So obviously that's tongue in cheek. But I will say that solar has proven its value on the battlefield, and it's proving it today in a variety of applications. And really important to note that there's still a lot of untapped potential as solar in the expeditionary environment continues to improve, becomes integrated with hybrid power systems, which really can start to paint a picture of an expeditionary energy future that looks very different, and it takes full advantage of these digital capabilities, but with a lot less baggage associated. Oh. Okay.
We also can take in power from solar
Get the sound up.
capability as well as fuel cells. What it does for you is it reduces your logistics footprint in terms of, you don't have to provide as much fuel for your generators out in the field.
So I'll just note, those are Nishati trifold Endurance 105 panels that are part of the Marine Corps green system under the name PAM, or Portable Array Module Expedition. Not the ideal employment method, laying them on the ground, but it works.
So what are these things? Solar panels provide power to the heat, which is a generator, battery, hybrid electric. Runs off generator for a certain time to charge batteries, then runs off the batteries to provide tactical power to the columns over here that we have set up. Pretty much once we set up these solar panels, it's going to take 90% of the load that they need to power up, and we'll be running off mainly solar power.
Why is that important in a combat environment?
One, we don't want to run the generator. Let's say the enemy's around us. We don't want them to give away our location. So we have the batteries for that, and also the batteries last longer with the solar power, and it's fuel efficient. It's runs about 4 hours generator watch for generator, and then about 14, 15 hours on battery with the solar panels. So the fuel that we're using is really nothing.
And what this is going to do is it's going to allow the power to extend so that way we can actually move our solar panels around depending on the direction of the sunlight. It's actually it's pretty amazing. We learned a lot of things. We're saving a lot of fuel. Also, we're saving on weight for height mode. And what height mode is it's more like a tactical quiet mode. Still producing the power, 3.5 kilowatts to the COC over here. At the same time, it's using the power stored from the solar energy. I've talked to the Marines over here at 112, and a lot of them are they're pretty amazed by it because they didn't know it was on the whole time. What they like about it the most is, when they're sleeping, these guys are QRF Marines right now. They're training for a quick reaction force team. So basically, they have to get up and go like in a split second. That being said, they can still get their sleep. That way they'll have that energy and they're not as fatigued for when they need to get up. So they really like it a lot.
So I jumped ahead there an extra slide, but I'll kind of go back and recap. That was an effort that took place about 1.5 years ago as the Marine Corps is doing some developmental work on different concepts for hybrid power, in this case a trailerized hybrid power system. But I thought it actually did drive home some of the points on this slide that I jumped over. And you've probably heard some of these claims, but I think one of the key takeaways is that when you talk about renewable energy and hybrid power increasing combat effectiveness, that means different things to different people, and you heard some of that in that video. It depends on your role, right? So if you're a utilities person or a generator mechanic, that means one thing. It may mean that now you're not spending as much time fixing generators that have been wet stacked. It may mean that you can focus on other things. If you're a communications officer, it probably means reliable communications, or at least backup for your critical communications. And that's one of the places where this is demonstrated, where solar and energy storage is demonstrated its utility on the battlefield. If you're an infantryman, obviously, as you heard there, it means you may get better rest, and it also means that in certain tactical situations where quiet or silence is a necessity, it has some value for maintaining your situational awareness and communications capabilities. And finally, if you're a bulk fuel refueler driver, it may mean one less trip a week or a couple less trips a month hauling fuel in an IED-laden environment, and that's a very real benefit. Okay, let's skip ahead. There we go. So that kind of leads me to the point of, who is Nishati? What do we do? Nishati actually is Swahili for energy, so it literally is energy. We were founded in 2014, just past our 2-year anniversary as a woman-owned small business and small disadvantaged business. And what do? We deliver solar that works in the expeditionary environment. Okay, we apply technology that is kind of cutting edge across our different products, and we bring what has traditionally been, the high-performance monocrystalline silicon solar that you would want to put on your roof, now into an expeditionary environment in lightweight form factors and packaging that makes sense for expeditionary environments, that can last in the high handling and harsh environments that means, and ultimately can add value in terms of capability. We're teamed with several industry partners across the hybrid energy space, and also some larger providers as we kind of branch into other commercial space as well. So this slide basically summarizes our product lines of operation and our approach to product development. We basically break down our products into expeditionary, semi-permanent, and permanent solar. So kind of in reverse, permanent solar, we're talking about your bigger arrays, your more commercial scale residential, and that's kind of a new area for us that we're working into. But those first three bullets under products describe our expeditionary capabilities. We break it down in terms of our solar panels, the Endurance series, the Expedition, which is the array, and that includes solar panel capability and a deployment mechanism, so some kind of a rack system, kind of like what we're showing here next door. And then the Outpost system, which now brings in some balance of systems like battery charging capabilities, interfaces, cables and connections to have various applications from from BB2590 lithium batteries to 12 volt, 24 volt lead acid and AGM recharging capability. And I'll talk more about the product that we're showing here. The bottom half of this slide really talks about what are the key things that we think about as we're developing products or looking for product improvements. It's all about reducing size, weight, and complexity, building in ruggedization, and trying to bring the maximum performance to the battlefield in a form factor that meets the needs for a mission, for a particular application, and for the environment. So this isn't just theory, we've actually done it. These are some of the initial technologies that developed through an SBIR via the Office of Naval Research that was in support of the Marine Corps' Ground Renewable Expeditionary Energy Network system. Basically, the initial program of record system they fielded was fielded with large panels, and on the next slide you'll actually see a good comparison of this. But taking commercial glass panels and basically trying to ruggedize those and package them for military use. Our system then reduced the weight by 60% and the volume of that by 70%, but maintained the performance. And that's where I talk about bringing that kind of higher end solar capability into packaging that's going to survive and is going to be able to meet the need and package and be portable for the warfighter. And this slide actually talks about that base unit or that flagship system that has been fielded to the Marine Corps as their advanced integrated solar panel case assembly, which is basically a tech insertion to their program of record. Again, you see in the center the comparison of the older system versus our system in terms of the dramatic improvement in size and weight. And then the other aspects that are unique are that it's very quickly deployable and repackable by one person. It can be transported by one person, and it all meets two-person lift requirements. It can also be packaged and palletized for military lift. It has passed MIL standard 810G testing, so it's been through drop testing and all of the other the environmental testing and vibration testing and so forth has survived that. And I would add that it's mission configurable. So while you see everything packs into the Pelican case, the nice thing about it is you can break these components out, and for a particular mission you can spread load the components. So the rack itself actually rolls up, can be carried with handles that's part integrated with the rack system. The panels can go into a soft case, which I have over here on display as well. And now you can throw it into a vehicle, you can throw it into a helicopter for helo insertions, and that sort of thing. So as we start to get vehicles that have a silent watch mission and have we heard about 6T lithium batteries, for example. Now you have an ability at the hull to put this out quickly, to be able to maintain your silent watch, keep your batteries topped off, and then pick it up and go on the move again. And that's part of, I think, the vision of where solar kind of has some new application that hasn't been tapped to date. We're really excited about a new technology, and I've got it in the panels that I'm showing here today, that we're inserting into our Endurance series. And this is a new engineered interconnect architecture and materials that dramatically improve the durability and lifetime performance of the solar arrays. Particularly, again, making that monocrystalline silicon even more viable, but also opening up new opportunities in terms of conformal applications, direct bonding of very thin, lightweight silicon, crystalline silicon to different applications, be it vehicles, be it UAVs, so on and so forth. So that's all, you know, untapped at this point, but it's certainly something that we see as great potential for this. Initially, we're inserting it into the system I showed you on the previous slide, and in this next slide, I'll kind of give you the description of the payoff. It's going to be a drop-in to our Expedition arrays, and we're also taking this technology and using it in everything from small backpackable 25-watt panels up into commercial scale, more traditional panels, because on that side you've got payoff in terms of the weight, the ability to package it much lighter, reduce your structural requirements, reduce your labor costs, and so forth. On the Expeditionary side, where it really makes a big difference, you're handling panels a lot. You're potentially beating them up more than you would if you put them on your roof, where they were meant to stay for 20 years. Now you need something that really gives you that added protection, the mechanical reinforcement it provides, the resilience to thermal cycling and fatigue that are some of the failure points in traditional solar panels. One neat fact that I'll tell you about the 4-panel array, you see in the picture there, and it's, you know, similar with the current panels that are being fielded to the Army and to the Marine Corps. One of those arrays will charge a set of two BB2590 batteries as fast as you can charge with a generator or by plugging it into shore power. So traditionally, a lot of times, a lot of the thin film solar and the other systems that have been out there, they haven't been thought of as being able to do that. You can't take a dead lithium-ion battery and start it and get it charged up. You can't charge as fast as you can on generator power, on shore power. That's what we're talking about when we say we're bringing higher performance solar capability now into the expeditionary environment and making it viable. Certainly be happy to talk to anyone about the technology I've got with us today and what we're showing over to the left. Afterwards, it would be easier to kind of talk through that technology while we're looking at it. But again, we'll certainly take questions here. I've got one more slide, and this kind of tells you we're a company that's evolving. I kind of gave you the pitch about how we think, what we're looking at in terms of product features, attributes, and so forth. And now we're taking that and trying to expand down the scale and up the scale. So things as small as a 25-watt backpackable type system, which now has some scalability to it as well, or will have some scalability to it, to get up to 100-watt capability, so you can do some serious battery charging. And then again, looking at a new packaging in that Expedition series where we get more power in a single container with some of those very similar characteristics to the system I described earlier: single-person transportable, 2-person lift, ruggedized, and so forth. One of the other benefits of that system is the footprint when it's deployed will be smaller. And finally, we are taking some of this technology and working several projects to actually integrate into things like rigid expeditionary facilities, because it kind of gives you some opportunity to do that. And as I said, and then we have our kind of commercial lines. If I didn't mention it, the system, the Expedition system that I've mentioned as a Marine Corps insert to the Marine Corps Program of Record, we've delivered now almost 3,000 systems to the Marine Corps and to Army's persistent surveillance program under Project Manager EOIR payloads. We're looking to build on that. We think there is a lot more out there in terms of remote communications, be it SATCOM, be it other surveillance capabilities and so forth, and we think we have an edge in being able to meet the needs and tailor our packaging for those different applications. So with that, Bill, I'll open up to questions.
Okay, Rick, you and I, in the last 3 to 4 years, have had a front seat of watching the evolution, spiral, improved performance of renewable power and hybrid power. We have seen the weight reduction, we've seen durability increase, and we've seen efficiency. Now it appears that the demand signal, while it may still be there, it's certainly a little weaker than it has been in the previous years. Is this going to stop or stunt what we saw is a pretty steep linear growth in capability in solar, renewable power, and hybrid power?
Sorry, are you asking me from the technology side or from the political side?
I'm going to remind you this is recorded. So straight from a business side, I thought we had the community standing up and doing everything they can to improve performance and capability now that the signal seems to be weakened, are they still going to do that? Are you still going to do that as an industry leader?
It's a great question. I mean, it's certainly something that we think about in terms of our diversification. The need to find crossover markets from DoD. There's still headspace in the technology, I believe. I think that again, what we're opening up here with kind of this new technology are opportunities that maybe folks haven't thought of. I think there's a lot of that out there. I think even with the original fielding of the Greens system, for example, in the Marine Corps, it really took a show me kind of approach for folks to realize how it could be applied. And when you think about it now, we've got so many systems out there that either have organic batteries to the system or have battery backup. You know, there's already an inherent energy storage capability that's proliferating across the capability sets. That is an opportunity to plug in where it makes sense in terms of the concept of employment. So I think there's a lot of rocks that haven't been turned over yet, or a lot of programs that maybe haven't considered how they might integrate novel solar type solutions or hybrid solutions. Maybe some of that is a lack of familiarity with the state of the art, or are there program constraints? And I think to maybe the point of your question, that if there isn't a forcing function that continues folks to be interested in it, is it going to wane? I think in the resource constrained environment we're talking about, that's a serious risk. And I think we've seen some of that in terms of hybrid power development.
Thank you.
Any other questions? All right. Thank you. I appreciate the opportunity, Bill.
Thanks, Rick.